Okay, so tonight our homework is on order of operations, and it should be a review because I know you guys have practiced order of operations before, but this is just a little refresher. So order of operations, it's just simplifying a numerical expression. And we say simplifying, not solving, because solving is when we have an equal sign. We don't have that right now. Simplifying numerical expressions using PEMDAS, or what we're going to see today is GEMDAS. I like to say GEMDAS more than PEMDAS, and I'll explain why. So what is PEMDAS? What is GEMDAS? The P or G stands for grouping symbols. Grouping symbols. So these certainly can be parentheses, but they might also be brackets. We might also see division bars, like if you have 3 divided by 1 over 6, that's a big grouping symbol. Okay, so we always have to simplify those first. Next thing is E exponents. And we should know what those look like, but that would be like if we had 5 to the second power or 6 to the fourth power. Okay. M, D. Now, I like to write this both ways because we always multiply and divide from left to right. So divide and multiply from left to right. And that is so important because so many of us forget, and we hear PEMDAS or GEMDAS and we think that, oh, well, the M comes first, we automatically multiply first, but that's not the case. You do whatever comes first. So if you had something that looked like this, like 6 divided by 2 times 3, you would divide first because that's what comes first when you're going from left to right. If you had something like 2 times 4 divided by 2, you would multiply first because that's what comes first when you read from left to right. So just be very, very careful about that. It's one of the most common mistakes I see. And then the same thing with add subtract. It's not always add subtract first. It's, again, add subtract from left to right. I'm just going to abbreviate. So if you had 2 plus 3 minus 4, you're going to do addition first. If you had 7 minus 6 plus 2, you're going to do subtraction first based on what comes first, left to right. Awesome. All right. So the first thing we're getting into is absolute value. Again, not something new. We're going to have a little refresher, and it's a number's distance from 0. So on a number line, we talk about distance from 0. So if we have a number line, and 0's here, and 5's here, the distance is 5. Negative 5's here, the distance is still 5. So for example, the absolute value of negative 5 is just 5. Okay. Absolute value is also considered a grouping symbol, so I'm going to add that to my grouping symbols. Absolute value of x is a grouping symbol. That's really important. And we could see that here. Let's say we had an example that said the absolute value of negative 12 plus the absolute value of 3. We have to simplify the absolute values first. The absolute value of negative 12 is just positive 12 plus absolute value of 3 is just 3. Simplifies to 15. We also see absolute value with subtraction. So let's say we had the absolute value of 24 minus the absolute value of negative 15. Oops. Okay. Absolute value is 24. is just that, minus the absolute value of negative 15 is 15. However, notice this subtraction symbol did not change. It was only the negative in the absolute value that we got rid of. 24 minus 15 will leave us with 9. So let's get into a couple examples of order of operations. So we have 135 divided by, and then a bracket, 5, parentheses, 7 minus 4, close parentheses, 2, and bracket. And I always like to write off to the side GEMDAs. To kind of keep track of where I'm at. And the first thing I ask myself, is there a grouping symbol? Yes, there's a lot of grouping symbols. We've got these brackets right here, and we always start with the innermost grouping symbols. So we're going to start with that 7 minus 4. So 7 minus 4 leaves us with 3 squared. Everything else stays the same. Do I have grouping symbols still? Absolutely. But within those grouping symbols, we have an exponent. So we need to do 3 squared. Gives us 9. Everything else stays the same. Okay, I did my exponents, but I still have some grouping symbols. I have these brackets right here. And 5 parentheses 9 means that there's an invisible multiplication. Anytime you have parentheses around numbers or variables, it means multiply. So 5 times 9 gives us 45. Okay. Now, we don't really need these brackets anymore. The reason I kept them is because I wasn't sure what symbol was in front of them. Like, for example, if there wasn't a symbol, then we would need something there to say that we were multiplying it. But since we're dividing, we can actually get rid of those brackets and just write it as 45. And we can certainly simplify that. 135 divided by 45 is 3. Let's try another one. So this one has a large grouping symbol, division bar, and we have 2 times 4 squared minus 8 divided by 2. All of that over, in parentheses, 5 plus 2 times 2. All right, my GEMDAs. I know these, I go left to right. Okay, so I'm just going to focus on the top part. Okay, so I don't really care about the bottom part right now. I'm just going to focus up here. All right, so looking up there, are there any grouping symbols? Well, this whole thing is a grouping symbol. So within this, no, there's no grouping symbols. Are there any exponents? Yes, this 4 squared. So that's the first thing I'm going to worry about. So I have 2 times 16 minus 8 divided by 2. And all of that is over 5 plus 2 times 2. Not worried about that yet. Okay, can I multiply or divide? Only worried about the top. Yes. Going from left to right, I have multiplication first. So 2 times 16 will give me 32 minus 8 divided by 2. All of that over 5 plus 2 times 2. Okay, still working on the top. Is there any division multiplication? Absolutely. I've got this divide by 2 right here. So I have 32 minus 8 divided by 2 gives me 4. All of that over 5 plus 2 times 2. Notice I haven't even touched the bottom part of that fraction yet. Okay, let's simplify the top. I can subtract 32 minus 4. That leaves me with 28. And then I have the bottom. 5 plus 2 times 2. All right, the top is completely simplified, so that's done, but we definitely need to do some operations on the bottom. First thing on the bottom is grouping symbols, absolutely. 5 plus 2. That becomes 7 times 2. We can certainly simplify that. We have 28 over 7 times 2 is 14. And then the last thing we try to do is, can we simplify this? 28 divided by 14? Absolutely. That's going to be a final answer of 2. Okay, last one to practice. If you're feeling confident, you can go ahead and start practicing, start working on the practice problems for homework. But if you want some more help, please feel free to try this problem as well. So we have 5 squared minus 4 cubed, close absolute value, divided by 3. All right. Lots of stuff happening here. I see a lot of grouping symbols. I see these right here. And then I also see these absolute value symbols. Okay, I'm going to start here. 8 minus 3 gives me 3 cubed minus the absolute value of, well, within these we have some exponents. So let's do those exponents. 5 squared is 25 minus 4 cubed is 64. Absolute value divided by 3. Grouping symbols, we need to still take care of this absolute value. 25 minus 64 is negative 39. However, do not forget the absolute value symbols. We have not taken the absolute value yet. And then I've got 3 cubed over here. Okay. Still need to apply the absolute value. Well, the absolute value of negative 39 is just positive 39 divided by 3. This subtraction comes down, and we're left with 3 cubed up here. All right, next thing, we did grouping. Exponents, yes, 3 cubed is 27 minus 39 divided by 3. Okay, what am I going to do next? Well, do I have any multiplication division? Yes, 39 divided by 3. So that's going to give us 13. Bring that subtraction, so you have 27 minus 13. Let's simplify that. 27 minus 13 is going to give us a final answer of 14. Be sure you complete the homework and also view the YouTube video on how to watch these faster. If you're speeding through these, you can actually adjust the speed on YouTube. So make sure you watch my video on how to do that. All right, have a great night.